two configuration. As we know, we have already identified two configuration. One is called the star or Y connection. So it looks like I will have one coil that has terminal 1 and terminal 2. And then I have another coil. And we can consider this is terminal 2, terminal 1. And then I have another coil. So this is terminal 1. And then this can be extended. So this coil indicates the coil in the generator. It can be also in the motor, or yeah, it can be connected in the generator or the motor. So we can connect with these to the transmission line. So let's say I have a transmission line. So I will draw a different line. So we can have a red transmission line. We can have yellow. So yellow transmission line. And we can have blue transmission. Okay, so this is R, Y, B. Okay, so on the other side, it can be connected to anywhere. So we can just make it similar. So this is the part of the generator. And then we can have blue bars. So this is where we have the generator terminal we have, and that is connected with the transmission line. So these are the different lines of the system. Now, with respect to this connection, we can differentiate. So there will be a neutral that let us consider with the green one. So this is the neutral usually connected with the system. So this is N. Now, with respect to this connection, we can identify different quantity. So we can consider, we can take a look of the line, the voltage between these lines that we have. So in between these three phases, we can term this one as RY, or we can YB. So VYV, and VVR. Okay, so these are the line voltage we have. So in between two different lines, what is the voltage? What else we can define? We can define also between this phase to neutral voltage. So we can identify the another voltage that is called VRN. And then we can have VVN. And then we can have VYN. VYN. Okay. So these are the different voltage quantity we can identify. Now we can name this one depending on the voltage between the lines. They are termed as line voltage. So line to line voltage, or we can call also this one as line voltage, simply line voltage. And they will be specified as VL or VLL Or we can write a specific line between R, Y, V, R, Y, V, and V, R, B, or B, R. Okay. So anything we can mention. So between two lines, what is the voltage, and between line to line voltage, whatever it is preferred, we can mention. Now another voltage I can see from the figure in between line to neutral, from any line to neutral. This line you can specifically identify these voltage will be only across a single coil. So this voltage from one line to neutral, this is actually a single coil across a single coil. Only on the other hand, if you consider the line to line voltage, this is actually the voltage between two coils. So it depends on your arrangement. So this is RY. So between two coils, okay? So whenever it is any voltage, any quantity that is related with a single coil, individual coil, that is called the phase voltage. Here it is phase voltage. Usually this is termed as phase voltage, no other name. And this can be written as R, N, or V, VN, or V, R, YN. But neutral point is not in the other configuration that we learn. So sometimes this is called also V theta. Theta means is the phase voltage. Okay. So these are the two voltages. Now, if you take a look of the current, we can see the similar thing. We can see that this current is flowing through this line, IB, and this IR, and this one is IY. So these are the three line current. Now, if you go back to individual current, that will be called the phase current. So here is the phase current. We can consider, let's say this is B, and this is IA, and this is IC. So these are the three currents. So similarly to the voltage and the current, they can be also different voltage, line voltage, and to the coil, individual coil is the phase voltage. So that means line current and the phase current. Line current, IB, IR, IY, and the phase current. So that would be I theta, and usually theta related to R or Y. So in this way you can write down. Okay, now what is the relation between these two quantities? We have learned that both voltage and the frequency, both voltage and the current, they can be line voltage and the phase voltage. Now, what is the relation between this line voltage and the phase voltage? We will not go into the derivation or how we can derive, but we will take a look what is the relation. The only easiest way to remember is that you can see here, as I have mentioned, the line voltage is between two coils and phase voltage is one coil. So there should be a factor that is relating, and phase voltage will be smaller. And what is the relation? Phase voltage, line voltage, and the phase voltage theta. What is the relation? As I have mentioned, this is line voltage in between two coils, so that should be VL should be greater than V theta. and there should be a relation between these two with a factor, and that factor is square root of 3 is the factor by which they are related. That means this VL is larger, so that means I have to multiply this one with the square root of 3. So any phase voltage, if you multiply with square root of 3, that will give you the line voltage if there is a difference. Now here you can easily see that these voltage should be different because it is in the line voltage between two coils and phase voltage is a single coil. So that should be a difference, and smaller one will be the phase voltage that will be multiplied with the square root of 3. That will give you the line voltage. Now, what about the line current and the phase current? So do you find any relationship with the line voltage? Let us write down this is theta with the same, it should be theta R, this one theta Y, and this one theta B. Theta B. Yeah, that will make simplified, everything is same. Now, what is the relation with IB, the line voltage or line current? Or simply I can write down this is the line current. So line current and the phase current or theta. What is the relation? Now, if you take a look of this relation, derive the relation, we don't derive, we analyze the current flow, then you can see the I theta R that is generating, that is coming out of this coil and then passing through this line and then coming back here, then it becomes line current. So from here, there is no way to, or we have not taken any current to other direction. It is the same current that is flowing through this coil is flowing through this line. So that means this is the same case for all the three coils. So same current that is flowing through each individual coil is passing through this line. So I can tell these two must be equal because there is no way this current can flow. So the same amount of current should flow between the line and the phase. So this is the relation between the star connection. So if it is a star connection, I can say this voltage relation between the voltage between the line and the phase is changing, is different, and they are related with the factor called square root of 3. And whenever it is line current and the phase current, they are the same. So they don't have any difference. Okay, so they are of the same value. And that can be easily derived by the phasor diagram. As we know, the line voltage that we are generating, they are of 120 degree apart. So I can consider this is my line R, and then my Y will be in this direction, Vy, and then I will have, so I will have, this will be Vy, and then we can have, this one is Vb. And we know this angle is 120 degree and this angle is 120 degree. This is minus 120 degree and that one is plus 120 degree. Now we can find out the phase voltage. So if I take a look of the phase voltage, if you take a look, let us trace connection of my supply. So we can draw this one, though we don't need to derive, but just to give you an idea. So if I have a coil here, So this one, this is the line voltage. We can consider this is R and this is Y. So this is RY. And this one would be equal to VRN, and this one would be YN. So in between this one. Now, if you write down the KVL, then VRY should be equal to VRN. So I can consider this is positive terminal. So I will have the positive terminal, and this one is the negative terminal. So I will have this one negative, and so this one will be the positive, negative, and this one is the negative. So I will have between these two, I can write down this one should be equal to this one plus this one. So this one would be Rn plus Vyn. So these are all vector connection. So that means I have to add two vector Vrn and Yn to find out Vry. Okay. So if we do that, so we can consider this is, let's say this is Rn, this is Yn, and this is Vn. They will be also 120 degree apart. So now if I want to find out Ry, that means due to this sign, this will be actually negative. And if we do the addition, that one of them has to be taken in the opposite direction. So this will be the same, but it will be Yn. Now, if you add them, these two vectors, then this will be your Vry. Okay. And this angle is actually, because these two are the same magnitude, this length is same, because I am considering that the balanced or symmetrical system. So I will have the length will be the same, but they will be separated by 120 degree. Now, whenever I will add this will be, so this one is 120, that means this one is 60, and this resultant would be 30 degree. So that means this is the line voltage, and this is the phase voltage, and there will be 30 degree phase shift between the line voltage and the phase voltage. Now, if we do all this addition that we are not interested, so then we can find out this relation that we have written. This relation can be found that this line voltage will be square root 3 times the phase voltage. Okay. So from this relation, we can derive this one. And this 30 degree, we have to keep in mind that this line voltage and the phase voltage, their angle will be 30 degree separated. That means if I have, so this Ry will be leading by 30 degrees. So Rn and Ry. So Rn is, if you consider this one is 0, then this one, this Ry will be 30 degree apart. So it would be Vry at an angle of 30 degree. Now we can draw the other phase. So other phase current, phase voltage similar to this one. So it would be 30 degree in this direction. That means it will be moving 30 degree on the other direction from here. So Yn, Yb would be equal to 30 degree apart from this one. Because you will extend this one, then probably you will get somewhere here. RVYB, and this is the 30 degree. And then the other one, the third one, you'll find out between the R and V. So this is VBR. So this will be negative. Then you will find out this one, and this will be 30 degree. So this is the phase, this is the line voltage, and this will be the phase voltage. So phase voltage, the line voltage and the phase voltage are separated by 30 degree. And from one phase to another phase is 120 degrees, similar to one line to the another line. This is also 120 degrees. So from here to here, it is 120 degrees. Okay, is this clear? You don't need to derive, but just to remember that what is the relation, how we can find out the relation between the line voltage and the phase voltage. Any question or anything? Because we need to understand this one, we will do a lot of numericals with this. No question?
No.
Right. That's good. So this is about the one of the connection. This is called the phase connection, the star connection. The other connection is the delta connection. So we'll write delta connection. Or mesh connection. So if you have delta connection, we are considering this will be look like delta. So we can consider terminal 1 and terminal 2. Then we can have this one. And we can have this one. So terminal 1, terminal 2, terminal 1, terminal 2. And then we can extend this one with this line. So this, and this. So then it can be connected with the line. So we can consider this is my red. And then yellow. And blue. Okay, I will give you some time to identify different quantity of this one. I may ask you to share your screen and then say what is the different voltage, current. Okay, so this is R, Y, B. Now, what is the different voltage and the current in this configuration? So this is just quickly I can see. In practical, you will find out these three coils. They can be like this one, as I have shown you. So you have three coils, and you will terminal 1, terminal 2, terminal 1, terminal 2, terminal 1, and terminal 2. So what you have to do in order to make this connection, you can connect in this way, 2 to 1. And then this 2 to 1. So then you have this connection Y. Or you can do the other way also. So you can have, just go to the page. So you have three coil. You can have number 1, number 2, and then other coil, number 1, number 2, and then the other coil. So you can do the other way. So this one will be connected here, this one will be connected here, and this one will be connected here. So this will be R, Y, B. So depending on the requirement, you can do this kind of connection, but both of them are similar as shown here. Can you identify different voltages? Which one, how will you mark the phase voltage, line voltage, and phase current and the line current? you're done, just let me know. Anybody has done? Trying? Are you here? Or you are there for the dinner? Taking your dinner?
I haven't
God is
drawn
here?
the line and phase voltage are just equal.
Yeah.
And then
Sorry, I missed the question. I was in the bathroom quickly.
Yeah, we need to find out or mark the phase voltage, then line voltage, phase current, and the line current for the delta.
Oh, okay. Must I draw on a piece of paper and
Yeah, that would be useful. Done.
Yeah.
Okay, so then let us try to do it. So we have the line, so I can simply do the similar way, that star connection. So the line RY voltage is this one. Then we have VYV, and then we have this one VR. We will write VBR. Okay, then the phase voltage across each of the coil, right? So we'll consider this one is my phase voltage that is related with R. The terminal 1 is connected with R. That's why we are just writing it R, because we cannot actually determine which phase it belongs, because number 2 is connected with Y. So we just take a assumption that whenever is number 1 is connected, we will consider that coil belongs to this particular phase or line. So then this one would be VR, and we have this one would be Y, theta Y, and this one would be theta B, right? And the current that is flowing, that would be equal to this one. So this is IR, this is IY, and this is IB. Now, for the current in phase, you can identify the phase current. We'll just take a different color. So phase current in this one, I will consider number 1 is the positive terminal. So current will be going. So that means this is positive and this is the negative terminal. Similarly, this is positive and this one is the negative, and this is positive. Sorry, this is positive and this one is the negative. So that means I theta. So this current is related with a single coil. So is phase current. So similarly, this one from positive, so it is going towards positive. So it would be going towards positive, and that would be I theta B. And this is going towards positive. This is called I theta Y, right? So these are the phase current inside. It looks like a cyclic rotation, having the cyclic rotation. Now, if I want to find out the phase voltage and the line voltage, the relation, then we can just take one phase, and this one is the phase. I have considered RYB, so R will consider positive, and Y will consider negative, because Y is written in this second. So that's why it's the negative. Now, this particular coil, we can consider a closed loop if this one we consider that this is somehow is connected with my load or with a voltage source. So I am measuring the voltage, so we'll consider a voltage source is connected. So this is just an assumption to consider that we are writing the KVL. So if I write the KVL, then this is the positive terminal and this is the negative terminal. So if I start from this particular point, then it will be minus V theta R, then this one will be plus V RY. So if I just write down KVL, then it will be minus V theta R plus V RY should be equal to 0. And then you can just write down VRY would be equal to V theta R. So this is the relation that, and this is obvious, that if you take your multimeter and place your multimeter here, is a voltmeter, and if you connect your positive terminal here and negative terminal here, then whatever the voltage you will find out, it will be the same as if you place a voltmeter here and connect one terminal here and another terminal here. So they will give you the same voltage. And this is true for all the phases. So that means in delta, we have a relation that phase voltage is equal to line voltage. So I can write down VL is equal to V theta. Okay. So this is straightforward. If you have a delta connection, the line voltage and the phase voltage will be the same. Now, what about the current? So if you take a look of your current, then if you take any of the node, let's say this node, so from this node, this current IR that is going outside, and then this current is actually I theta B, and this current is I theta R, right? So what we can write down from here, this current I theta R is entering and other two currents are leaving. So you can write down that I theta R plus IR plus, sorry, minus I theta B should be equal to 0. Okay, so that means IR, the line current, is equal to I theta B minus I theta R, right? So this is the relation. Now, this should be done with a vector summation, right? So let us draw now the phase current. So all the phase current will be 120 degree apart. So if I draw the phase current, so I can start with theta R. This is my I theta R. Then 120 degree away, it will be I theta B. And then I'm considering the balance system. So balance system, it will be I theta. So this will be B, and this will be actually Y. So it's a positive sequence, R, Y, B, or it will be A, B, C. Okay, so this will be R, Y, B. Now what we have to find out, IR is equal to I theta. Yeah, so I theta R, so I theta B minus I theta R. So I need to extend this one, and that will be the same length. So let's say this is my IB, I theta R, that will be negative. Now if you add them, these two, then this will be your IR, and this will be creating an angle of 30 degree. Okay. So this is 60 degree, both of them are same, so that will be making 30 degree. So this will be the relation between, just checking, yeah. So this will be the relation between these two current. And if you do all this calculation, then you will find out that final result will be equal to square root of 3 I theta R. Okay, so this will be the related. So in general, I can write down IL is equal to square root of 3 I theta. So always the line current here will be multiplication. Though this minus sign might be misleading that I am subtracting, but in vector summation, if you subtract, that can increase the value. So this summation is not this negative sign does not mean is the algebraic summation. This is the vector summation. And you will have always line current will be higher than the phase current. Line voltage will be higher than the phase voltage. So in delta connection, they are the same. But if it is a star connection, line voltage and phase voltage, there will be a factors. Line voltage, it will never be a phase voltage will be smaller than the line voltage. It can be equal in delta, it is equal, but in star, line voltage is higher than the phase voltage. So on the other hand, current is opposite in Y. The line in star connection, line current and the phase current are same because same current is flowing. But if you consider the phase voltage and the line voltage, they are having a factor of 3. And if you multiply the phase voltage by a factor of square root of 3, then you will find out the line voltage. All right. Any question? So this is the relation we have to keep in mind. And there will be, this relation is important to understand and to do any kind of mathematical relation, establish the mathematical relation. Any question regarding this?
No.
All right, any question? No?
No.
Okay, then I will share the other screen. We'll try to solve 1 or 2 problems. Let us start with this simple. Okay, so let us start with this one. So this is the problem. Let me see how many of you can do this. So we'll do for both the cases, star and the delta. So initially you start with the star and then we can do the delta. Let me know if you have any question. So this is the question. So you are given the line voltage 415, and you are asked to find out the phase voltage. That means the voltage from A to N. So you need to find out VAN and the current. So if it is a star connection, then we can do this one using simple relationship. So we know this VAN would be equal to VL divided by square root of 3. So we can just write down 415. We'll consider this angle is 0 degree. And then square root of 3. So that will give us, what is the value you have found?
$7.99.
The voltage, that's 239.6 volts.
239.6
volts.
volt. And that we can consider this is an angle of 0 degree. And then all the voltage will be the same. VBN will be equal to, now I have taken this one as the reference. So that means BBN, I can write down that this will be 120 degree in the clockwise direction. So that will be 239. Though this has not been asked, but you just to give you an idea what would be look like, it will be 120 degree. So this is the balance system. Whenever you have balance system, then we can consider, because all the three load are the same. So this is considered as a balanced system. So that means the voltage will, or any quantity will be the same, but only the phase angle will be different. So similarly, the last one, VCN, that will be equal to 239.6 volt at an angle of 120 degree. This will be the positive. Okay, so we have found all these, and now we can also find out A and B, BAB from here. So this will be good example to do this. So in order to find out AB, so what we will consider, so that time I might be doing in hurriedly. So let us do it slowly and try to explain everything. So in order to write a closed loop relation, so I have VAN is this one, A is first terminal. So that means I will consider this one as the positive terminal and this one is the negative terminal. And this is also true. This current is entering into the load. So that becomes positive. This becomes negative. So this is similar here, VBN. So this will be the positive and this will be the negative. And in order to consider this one is a closed loop and I want to find out VAB, so I can just assume that I want to find out VAB, A is the first letter, so this will be the positive and this will be the negative. So this is VAV. So if I use this voltage, then I can consider this one as a closed loop, and then I can write down the KVL. So KVL would be equal to VAV, that will be minus, if I start from here, and then it would be plus VAN and minus VBN. So simply I can write down VAV would be equal to VBN minus, so it's minus, so it would be going, so we'll have plus, right? So let us just write down in two steps, that will be, so this will be minus, then this one is going on the other side, so this should be equal to 0. So this is going to the other side is minus, so then this is VAN. Okay, so now this one, if I remove this minus sign, so these are all vectors. So VAB should be equal to BAN minus BBN. or if I want to, we can also write down this one in a way. So this VAB, if I change this B letter is in the beginning, A letter in the end, then this vector direction is changing. So in that case, it may become plus. So VBN, BA should be equal to BBN minus BBN. Okay, so this is also true, but we want to find out BAB, so AN minus BN. So you can just write down, you can draw the phasor from this one, from this assumption that you have done, we have done. So we can draw the phasor of this one. So this is not part of the problem. They are not asking this to clarify our idea. So we want to do this one. So this is 239. So BAN, and then we have this one is BBN, and then this one is BCN, right? So that's what we have calculated. This is VAN is 0 degree, then minus 20 and plus 20. So this is this one. Now you have to subtract from VBN, AN, we have to subtract VBN. So if we add these two, that would be look like this one. So if we add VAN and BBN with the rectangular geometrical calculation, now what we need to do, we need to subtract. So I have to extend this one on the other direction. So I have to extend this one on the other direction with the same amount. Then it becomes minus BBN. And then I have to draw a rectangle. And then I have to connect this one. And that will be my BAB. Okay. So we can do this calculation. If I know AN and BN, then we can do this calculation and that will be your BB. So similarly, you can find out if we know this one is 30 degree apart and this is your 120 degree, then the next one would be AB will be 90 degree from here. So it would be 90 degree actually with the reference. So I can draw this one as 90 degree with the reference. So this will be, you have to extend this one, then BBN minus BCN will be BBC. And this one would be 30 degree away. So this will be extension of this one. So VCA. Okay, so based on the first letter, we can write down this is VA, this is BV, and this is VC. Okay, that makes sense?
Yeah.
Okay, so this is the clarification of this. So now what we need to do, what is the problem is phase voltage I have found the line voltage. Now we need to find out line current and the phase current. What is the phase current we can find out? So we know this voltage is given. Now we know this is 239.6 and angle of 0 degree. That angle we have make an assumption. So nothing is mentioned, so we have taken assumption. And we have given the resistance, so I can find out the current, right? So this is simple Ohm's law. So IAN is equal to, so this is 239.6, making an angle of 0 degree, divided by resistance is phasor angle, which always with the reference. So that means resistance is always in the horizontal line, XL or XC is the vertical line, and impedance is making in this direction and in this direction. Okay. So as it is mentioned as a resistance, so I can just write down 30 an angle of 0 degree. So if you do this calculation, what is the value? I think somebody has done it is 7 point something.
7.99.
7.99.
99.
So 99 an angle of 0 degree. So this is AN. So similarly, I can draw, because it's a symmetrical component, so I can draw the phasor diagram of this one. And with this one, I can also write down that my line current in this node, this is my line current IA. And in this node, I have only one incoming current and one outgoing current. So I can just write down IA is equal to IAN, and that should be equal to 7.99, making an angle of 0 degree. All right.
Yes.
So I can draw the other phases of the current. So it would be, this is my IAN. That means what would be the BN? It will be always 120 degree, making an angle of 120 degree. So it would be IBN, and this will be equal to ICN. So this is same as now our line current and the phase current are same. So this is equal to IA, IB, and IC. Now you can do the same thing, try to get the idea of the same for the delta connection, make this load connected in delta. So if you connect in delta, so I can just draw this one. Then try at your home, at your free time, try to find out the phase voltage, line voltage, phase current, and the line current. Try to draw the phasor diagram also. So this is A, B, and C. So 30 ohm, 30 ohm, 30 ohm. So try to do this, and that will clear your idea. And whenever you draw the phasor diagram, then you can get insight of the of this each quantity. All right.
Yep.
Any question?
Oh, good. Yeah.
No, yes,
No question.
no question. Okay, try this one, and I will try to arrange, set some of the question related to this so that you can do practice. Okay. All right. If you have no other question, then we'll just finish at this now, and then we'll meet again in the next week. All right.
Thank you.
Okay.
Thank you.
you.
Thank you, mate.
Thank you.
Cheers.
Thank you. Cheers. Bye-bye.
Bye-bye. Just stop.